Hey, Chan Physics, Mr. Block, and we're looking at the Unit 1 study guide. And so I've got the key up here, and what I just want to do is kind of walk you through it. And so the first problem is just a vector problem. So you just have to follow the words. So Adam drives 3 miles east from his house, so 3 miles east is that way, and 14 miles south that way. And so remember, when we add vectors, we do tip to tail, right? So we follow along like we're doing directions. And so then it asks us, draw the picture, which is what those straight lines are. Asks, how far did Adam drive? Well, that's the distance, and so we just add 3 plus 14. And then it says, what's Adam's displacement? Well, the displacement is the distance from where he started to where he finished, which is this dotted line. And so we had to know that definition. And then we would just do a squared plus b squared equals c squared to get what that distance is. Okay, and remember, when you do this, you have to take the square root of this number, because we're not solving for c squared, we're solving for c. All right, second problem looks hard, but it's not that hard. We have this vector right here. They're just asking us to draw the x and y components. Well, the x component is the one that goes along the x-axis. The y one goes down on the y-axis. And then when they ask us what the magnitude is, that's just the number. How big is it? And so we just count the boxes. 1, 2, 3, 4, 5. That's a positive 5. 1, 2, negative. That's a negative 2. The next one is asking us to explain these graphs. And so remember, at least in my class, when we did this, we always had a motion detector. And we said if we're moving away from the motion detector, the numbers got bigger away from us, and if we were moving towards the motion detector, the numbers got closer. And so this one says, what's this object doing? Well, first of all, we can see that it's moving away from the motion detector, so that's a positive motion. And then they're asking us, is it getting faster, is it getting slower, or is it moving the same? And when we have a curve like this, it says it starts out covering a whole bunch of distance very quickly, and then it starts covering less distance every second. And so this must be slowing down. All right. So that was this one right here. It's moving in a positive directors. The number's getting higher, and it's slowing down. In this graph right here, we have to remember, we have to look at what kind of velocity, or what kind of graph is it. This is a velocity graph. So it says describe the motion of the object in simple language. Well, the bottom line is it is slowing down. It's going from negative 15 meters per second to 0 meters per second. So it's slowing down. And it's also moving in the negative direction because it starts here in the negative. If it was up here and moving down here, it would be moving in the positive direction, but still slowing down. And so then it says calculate the acceleration of the object from the graph. Remember, there's 3 things that we can find. From a position versus time graph, this one right here, slope equals speed. From a velocity versus time graph, slope equals acceleration, and area equals distance. And so it says first, it said calculate the acceleration. Well, we're going to calculate the slope. And slope is rise over run, or 15 divided by 8. And it says calculate the total displacement, so we know that the total area of this triangle is the displacement. So we just do 1/2 the base times the height, or 1/2 8 times negative 15, or negative 60 meters. All right. The next one is a free fall equation. How do you know it's a free fall equation? You got to be able to recognize that when they throw something up, down, or just drop it, that's a free fall equation. And when that happens, then we know that we're going to have to put A as negative 9.8 in our list. And so when we make our list of all the things we have VI and VF and delta X. So remember our equations, the 2 on the right have delta X on it. Which one has both velocities? The one on the far right, that's this one, and we use that to calculate the velocity. Our velocity, because of the squares, makes it really difficult for us to come up with these numbers, these negative numbers. So we have to just assume, right, that if something is thrown straight down and it keeps falling, it's going to end up with a negative. So that's why I got the negative there, if you were wondering where that came from, because it was a positive number. But when we have these squares, we have to like look at our idea of understanding to get that right. All right, last one. How long does it take for the bolt to hit the ground? Well, now we have the final velocity and we're looking for the time. And so we can use this equation. All right, number 6, quarter flip straight up. And we got 2 different times, 1 second or 3 seconds. We're going to use the same equation for both. And all we're trying to do is interpret the number. So when we get a final velocity of 10 in the positive direction, that must mean it's going up. And when we get a final velocity in the negative 9.4, that must be going down. That's why I said here it's going up. Here, for the question B, it's going down. All right, softballs hit straight upwards at 30 meters per second. How much time does it take to reach the top? Remember, this is a trick question. They hide the information in there. So we get VI is 30. They ask us for a time. We know it's free fall, so negative 9.8. We're sitting there with just these 3, and we're going, what? We don't have enough information. We need the 4th. We need the 4th. And the 4th is hidden in this idea that at the top of the path, the final velocity is 0. All right. These next ones you can look at. They're really just simple 4-column method problems. You just list them out, find the equation, and solve. And so if you have some trouble with them, it just means that you're just not concentrating on creating that list that you need to do. Okay? All right. These ones right here, I can just tell you right now, they're really a little bit new to you guys. Take a look at them. If you have any questions, we can explain them to you. But really, the bottom line is we should know that this is a position versus time graph. This one is covering more until it gets to right here, and then B starts covering more until it gets there. That's the stuff that you really should know. Okay. All right, tough one right here, but we kind of cut it out. We actually had more of this problem over here, but we cut that out. So we're just saying, what does it look like in the 3 types of graphs to have something roll down the ramp? So when something rolls down the ramp, it's moving away from the detector, so it's going to be moving in a positive direction, and it's going to keep getting faster, which means that the line's going to go up. So that's the position versus time graph. All right, the velocity, anything that's moving with gravity, even though it's like on the board here, it's still being pushed by gravity. Gravity is going to accelerate it at the same rate, and so it's just going to get faster and faster and faster and faster at the same rate. And so we get a line that goes like this. And right, so acceleration is the same rate. I've got it negative. Miss Moise's got it positive. I think it's a negative acceleration because it's going down the hill, but some people might say it's a positive acceleration because it's getting faster. Either way, I don't think we're going to count anything wrong on that one. All right, number 12. Anyone, if you guys are listening right here in the room, number 12 is really important. It's going to be very likely that you're going to see something like this on the test. All right, so what you need to do is take the words and figure out which way you want to use the words. So if you read this one, it says you're going to have to sketch both the position versus time and the speed versus time graph. And it talks to you in words of speed. And so you can do this one either way. You could do the speed graph first. And so if I do the speed graph first, it says the car stays at rest for 2 minutes. Well, 2 seconds, it's at rest here. It moves at 10 meters per second for 5 seconds. Well, here it is, 10 meters per second for 5 seconds. And then it stops for 3 seconds. It stops for 3 seconds. So those words are speed words. And so sometimes it's easier to do the speed test first. And then you go to the position versus time graph. Now this is the harder one because you have to decide, how does my brain work? Something stopped for 2 seconds, doesn't move. It doesn't go anywhere in position, so it stays there. And you see these little dots that I've got here in my... This means that I said to myself, well, it's moving at 10 meters per second. That meant in the first second, it moved 10. In the second one, it moved 10 more. Third one, it moved 10 more. Fourth one, it moved 10 more. Fifth one. And then I drew the line to solve it, right? And so you can always think of that 10 meters per second in little bits and pieces. All right, this is just from your notes, so you should be able to get those. This is from your notes. Everything hits at the same time. All right, and then now we've got our horizontal projectile problems. If you're doing them the way I do them, you'll see that this is all set up in the same way that we've been doing it the whole time. If you're in my class, this is the way we do it. We always write what we know. We always use this little part right here to find time, this little part to find range, this little part to find the velocities. If you're scrambling, you're at the end of your ropes and you're saying, I don't know what to do, I don't know how to do projectiles, please just remember the final velocity in the x direction is always the same as the initial velocity in the x direction. If you write down just that on the test, you'll get 2 or 3 of the points out of 8. Okay? And 2 out of 3 out of points is a lot better than 0. So just remember that simple idea, right? That if something is launched in the x direction at 25, it's still going to be going 25 when it's about ready to hit the ground. Okay? This is another problem. This one, though, if you're in my class, what we did was I did this part. I saw that it had given me the time, so I knew that I could just put the time right here and leave this blank. I figured out the range, I figured out the velocity, and then I saw, oh shoot, they want me to find the height of the table. The only spot left was to work right here, so I plugged it into that equation and was able to find the height. All right, 17, tip to tail addition. Remember, so you got to go tip to tail. The resultant is the dotted line. And then what are ways to get ready for the test? Watch this video. Look at your quizzes, because we're going to hopefully draw from, not from the questions from the quizzes, but questions like the ones from the quizzes. But Miss Moise, if you're in her class, she's got a whole list of different ways that you can study for the test. All right, hope that helps you guys. Always come here for help. If you're not in my class, you've got a little bit more time, but my class has this test on Wednesday right away. And so watch this video, email me. If anything, we could always get in a meets and I'd be able to explain something to you. All right, bye.